My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are going to review paper titled, Plant Organic Matter in Palsa and Khasyrei type Mires, Direct Observations in West Siberian Sub-Arctic. The northern peat accumulating wetlands, or peatlands, are estimated to cover about 3% of land surface. Despite that, they are often considered as huge reservoirs of soil organic carbon. Since the last glacial maximum, West Siberian peatlands accounts for about 36% of the total pool of soil carbon in Russia.
That's interesting, Higgs. The zone of flat Palsa Mires in western Siberia coincides with wide spread of permafrost. It is located to the north of Siberian U-Valley, and its area accounts for 30% of the entire West Siberian region. Both climate change and change in water balance were found to affect productivity of grasslands. The permafrost also affects productivity of northern ecosystems.
In this study, the researchers test the hypothesis that 1. The climate affects the same types of mire ecosystems in different geographical locations along south-north transect in western Siberia, and 2. A decrease in temperature results in a decrease in net primary production of plant communities in the north.
The study revealed that both the biomass and net primary production in the wetland ecosystems are largely constrained by nutrient supply in soils, which also depends on water content in root-inhabited soil layers. Biomass and net primary production reach high values in rather rich in nutrients hollows. But these values are much lower in the poor in nutrients hummock or Palsa sites, especially in presence of permafrost.
Wow, Boson, there is so much to learn about Arctic environments. The study reaches certain conclusions in which both soil properties and climatic conditions have a significant impact on net primary production, and the features of plant organic matter. The same factors also determine net primary production values in wetlands or peatlands at the low end of natural ecosystems in the boreal regions of western Siberia.
Overall, the researchers conclude that the south-north climatic gradient in western Siberia is the main driver of plant organic matter accumulation. It was found different across mire ecosystems of the same types, but located in different bioclimatic regions.